Hello students, let us solve this Irodov problem number 1.15. An elevator car whose floor to ceiling distance is equal to 2.7 meter. There is an elevator having distance d from floor to ceiling. So this distance d is given 2.7 meter. Starts ascending with constant acceleration 1.2 meter per second square. This elevator start accelerating in upward direction with constant acceleration 1.2 meter per second square. Let me call this acceleration a equal to 1.2 meter per second square. So this data is given. Again the distance d is given. Distance d equal to 2.7 meter. Okay. 2 seconds after the start, a bolt begins falling from the ceiling of the car. Now what happened at time t1? T1 equal to 2 seconds. A bolt from the ceiling starts falling. So this bolt detach from the elevator and starts falling. After some time, what happened? This bolt strike the floor of elevator, but elevator is moving upward, so it will go up, and the bolt go down and strike the floor. So after time t2, bolt strike the floor of elevator. Okay, the bolt's free fall time. So we have to calculate how much time bolt will take to strike the floor. Okay, second, the displacement and the distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft. Elevator shaft means with respect to ground. So we have to calculate displacement and distance covered by the bolt during the free fall. So the bolt is here and finally bolt is here. So we have to calculate both distance traveled by the elevator and displacement. So we have to calculate both distance and displacement of the bolt. So this is the initial position of bolt just before free fall, and this is the final position of bolt just after the strike. So how we can proceed the problem? So initially this is the situation of elevator at time t equal to 0. Now we can solve this problem in two reference frame, one with respect to ground and other with respect to elevator. So I use both the way, and let us see how we can calculate the things. At time t equal to 0, the floor of elevator is in touch with ground. So with respect to ground, the position of elevator is 0. Initially elevator is at rest, so its velocity is 0. Now at that moment it starts accelerating, so its acceleration is plus a. Okay. What is the situation of volt at this situation? Volt is attached to the elevator, so its position is not 0, its position is d. So its position is plus d. Its velocity is 0 because volt is attached to the elevator and elevator is at rest. So v equal to 0. What is the acceleration? Its acceleration is also plus a. Okay. Now we can calculate the same thing about volt but with respect to elevator. So what is the position of volt with respect to floor of elevator? So this is distance d. So relative position of volt with respect to floor of elevator is d. What is the relative speed of volt initially? 0. What is the relative acceleration of volt? 0. So this is the situation. Now at time t1, volt starts falling. So I consider just before t1. So just before t1, this lift will move with a certain velocity. I don't know, so I name it v1. So the velocity of elevator is v1. Position first. So position of elevator is from ground is y1. So its position is y1. Its velocity is v1, but its acceleration is a. Okay. What is the situation for volt? Now just before T1, this volt is attached to the elevator, so its position is y1 plus d. Okay, what is the velocity? Its velocity is also v1. What is the acceleration? Its acceleration is also plus a. So this is with respect to ground. What is the value with respect to elevator? So position is again d. Velocity, there is no relative velocity, there is no relative acceleration because this volt is still attached to the elevator. What happened just after T1? Just after T1, this position is y1, this velocity is v1, this acceleration is a1. This position is again y1 plus d. This velocity is v1, but just after detaching the elevator, the acceleration of this volt is downward and its value is minus g. So acceleration will change, but velocity will not change instantaneously. So just after T1, velocity of elevator and velocity of volt are equal. Okay. What is the things with respect to volt? Now with respect to volt, the distance is again relative distance is d, relative velocity is 0, but acceleration relative is not 0 because this is different, this is different. So relative acceleration is minus g minus a. Okay. What happened at time t2? At time t2, the position of elevator is y2. The position of this volt is velocity. Velocity is different. So let me call velocity is v2. Acceleration is again plus a. For volt, this position is the final position. So position is same y2. Velocity is different. I don't know. So I call it v3. And what is the acceleration? Acceleration is again minus g. What is the situation with respect to elevator? There is no distance, so distance becomes 0. Is there any relative velocity? Yes, there is a relative velocity. I don't know, so I left this portion. Is there relative acceleration? Yes, there is a relative acceleration of minus g minus a. So this is the complete data I have noted down. Now I have to calculate the volt free fall time. It means time T2 minus T1 when this phenomena happen. So I have to calculate time T2 minus T1. How I can calculate time T2 minus T1? So with respect to elevator, velocity, initial velocity is 0, distance is d, and acceleration is minus g minus a. So I use formula s equal to ut plus half a t square. But I use this formula with respect to elevator. So with respect to elevator, displacement is d. Displacement is with respect to elevator. Initial position is d and final is 0. So displacement is minus d. Okay. U is 0. So this will become 0. What is the acceleration? Acceleration is minus 1 by 2 g plus a into T2 minus T1 square. So this minus and this minus will be cancelled out and we got time T2 minus T1 square equal to 2d divided by g plus a. So time T2 equal to T1 plus under root 2d divided by g plus a. So this is the time T2. Again in the question given that T1 is 2 seconds. So let me calculate this number. I use the calculator because value are not some good form. So the value is T1 means 2 plus under root 2 into d 2.7 divided by g. Value of g is 9.8 plus a. Value of a is 1.2. So this came out 2.7 second. So the time t2 is 2.7 second. So I got the first answer. The ball free fall time is 2.7 second. But again we have to calculate this part, displacement and the distance covered by the bolt, but not in the frame of elevator, in the frame of ground. Okay. So what is the distance covered by the bolt during this time? So initially volt is there and now volt is at this position. So this is the displacement. This is not the distance. This is displacement. So what is this displacement? This is y2 minus y1 plus d. So this displacement S equal to y2 minus y1 minus d. What is the value of y2? This is the time. So we can calculate the y2 of elevator for time 2.7 second. So y2 equal to S equal to ut, u is 0, half a t square, so half a t2 square. What is the y1? y1 equal to half a t1 square. So displacement S equal to half a into t2 square minus t1 square minus d. So we know all the values, so I can calculate the value of displacement. So the value of displacement is a by 2 means 0.6 into t2 square 2.7 square minus t1 square 2 square into, not into, it is minus d is 2.7. So this comes t2 2.7. The value of this is very less. The value of this displacement is came out minus 0.726 meter. My answer is displacement is minus 0.726 meter. So this displacement is negative. This displacement is negative. Now we have to calculate the distance. In this case, is the displacement and distance are different phenomena? Yes, may be possible. May be possible that because this volt has initial velocity v1 but acceleration in the downward direction, so it will go up and come down. So we can calculate the velocity v1. Velocity v1 is, or we can calculate this in a good way like that. Let me make it simple. We have eliminated these things. Now, at time t2, at time t1, this is the situation of volt. It is moving with velocity v1 and its acceleration is downward and its acceleration is a plus g. No, not a plus g. Its acceleration is just g because we are calculating in the frame of ground. Okay. Now, how much time it will move? T2 minus T1. So in time T2 minus T1, it will go up and came down. So this is the displacement. So displacement S equal to ut v1 into t2 minus t1 minus half a t square, t2 minus t1 square. This is the value of displacement. What is the value of v1? We can calculate this value v1 just by putting formula v equal to u plus at. So v equal to u is 0, a into t1. So displacement S equal to a into t1 into t2 minus t1 minus g by 2 into t2 minus t1 square. So let me calculate this value. A means 1.2, 1.2 into t1, t1 means 2 into t2 minus t1 means 0.7, 0.7. 1.2 into 2 into 0.7 minus 9.8 into 0.7 square divided by 2. It again came out nearly the same thing. It is minus 0.721 meter. Minus 0.721 meter. It means that this elevator the displacement means displacement is negative, means at this point block is. So what is the distance? Distance is this length plus this length and plus this length. What is this length? This length is v square divided by 2g. So the distance is v square by 2g into 2, v square by 2g this distance, again v square by 2g this distance, and this is the displacement S plus S. So this is the distance. So what is the value of this distance? V square. What is the value of v? A 1.2 into time 2. So 2.4 meter per second. So 2.4 square divided by 9.8 plus 0.721. So it came out 1.30 meter. So my answer is 1.30 meter distance and displacement is minus 0.721. So this is the final answer.